Yo, what's going on? Good morning, everybody. Topic of today's video, we're gonna derive the formula for finding the nth term of a geometric sequence. Um, my sequencing, pun intended, is pretty bad because I should be making videos on, like just introducing the sequences and stuff, but hopefully I won't go off too off on a tangent, and we'll still be able to do that while keeping this main thing in mind. Okay, cool. So to understand this, you need to know these topics beforehand. Okay, so pause and read these things. Okay, and then I'm going to introduce the sequences a little bit right now to give you a motivation, to give you some motivation for what geometric sequences are. Okay, so first, what you want to do is you want to choose a number. Okay, so first, write that one, choose a number. Okay, so here I'm going to choose 5. Whoopsies. Okay, and then to choose another number, or should I just said choose 2 numbers. Okay, choose another number. Okay, so let me say here 2. Okay, let's keep it easy. All right, so now what I'm going to do is now take this 5. I'm going to make this my starting number. All right, so here I'm going to use this to build the list. So 5, right? And to get the next number, what I'm going to do is use the second number. So here 2. Okay, I'm going to multiply this by 2. Okay, so then it's 5, and 5 times 2 is 10. And 10 times 2, 20. 20 times 2, 40. Times 2 again, 80, and so forth. Okay, so then what we just did was we just created a geometric sequence. Okay, and with this starting number and this second number here, the thing that we multiply by, this thing is called the common ratio. Okay, for a geometric sequence. Okay, so what this basically is for geometric sequence is it's a special kind of sequence where you have a list of numbers in order, and to get the next guy in the list, you multiply by this, or equivalently, another way of saying that is if between any 2 consecutive terms in your sequence, right, the next guy divided by the previous guy is equal to a constant. So for example, if I lock these 2 in, right, so then this guy was the one that appeared after, so it's 10 over 5, that's 2. You could do this anywhere in the sequence. Okay, 80 over 40, that's also 2. Okay, and you'll get questions like this where they'll ask, is this sequence geometric? And the way you test that is by doing this. Okay, you could also do this with negative numbers. Okay, so like let's say that here, let me do this this little thing again. All right, so let me choose a number now, -3. Okay, so let that be the start. Okay, and then let me choose another number that I'm going to multiply that number by to get this. Okay, so like let's say 2. Okay, once again, let's keep it simple so I don't have to think so hard when I'm doing this, right? So then here, -3 times 2, right? That's going to be -6. Oh, no, I'm sorry. I said negative number. So let me make this as times -2. Okay, so -3 times -2, this is going to be a +6. Then you multiply by 2 again, it's going to be a -12. Do it again, 24. Do it again, -48. Do it again, 96, and so forth. Okay. So even when you look at this, just by the behavior of multiplying by a negative number, you see that the signs alternate. So this is also the sequence is like an alternating sequence because of the signs, but even so, this is still geometric. Okay, so you could think about geometric and alternating as like 2 different adjectives that describe the sequence. Okay, and you can do this trick again with the common ratio and see that it's going to be -2. Okay, great. All right, hopefully that was enough motivation. So now let's start this now. Okay, so now let's try to derive this for an arbitrary geometric sequence. Okay, so in both of these examples, this first number, this being 5 and this being -3, that was arbitrary, right? It wasn't really that important. So why don't we just start off with any number, right? So here I'm gonna let a equal the first a equal the first number in the sequence. Okay, and then let this, and then this number, that the second number I told you to choose to multiply this thing, that wasn't that important either, right? So here, let's call this r. Let r equal the common ratio. Okay, so now let's try to create the sequence using these two letters. Okay, so once again, the first guy is a, so this is the first term. Okay, well, to get the next guy, we said that we need to multiply by this common ratio r, so then just a times r. So then the next guy would be ar. Okay, so this is the second. Okay, and then similarly, to get the third, you multiply the previous guy, right? You get ar times r like this. But a better way of saying that is with the laws of exponents, that this is just ar squared. Okay, third, and then ar cubed for the fourth, and so forth. Okay, one more, let's just do fifth. It's ar to the fourth. And yeah, okay. So we know that the sequence looks something like this. And we want to be able to find out what the nth is, right? So the nth one, let's say that, you know, you go deep down the list and this is nth, okay? Okay. And this n is supposed to represent any term position, okay? So in order to do that, you want to look for some kind of relationship between the value of the term. So this is the value. These guys are the values. You want to see if there's a relationship between the value and its associated or corresponding position in the list, right? So for example, when I look at the first term and I see how many r's there are, well, there's 0 r's, right? So this is like saying this a is equivalent to saying a times r to the 0, which, you know, if you know that the 0th power, anything to the 0th power, with exceptions, but just say anything with the 0th power is like 1. But some people say that the base can't be 0. It's something weird happens 0 to 0. But yeah, okay. But here, so this is like the same thing as saying a. Okay, if I ask you for the second term, how many r's are there? This is like saying r to the 1. Okay, the third, r to the second, fourth, right? So the pattern is that it seems like that the number of r's that appear in your sequence will be 1 less than the position number. Okay, so that's going to help us. Okay, knowing that this position is the nth position, then, and using this relationship, then the number of r's that appear here will just be n minus 1. Okay, and we know that the a, which represented the starting number, that's going to still be there. So here, let me do that here. So here it's going to be a, right, times r times 1 less than n. So that's going to be r to the n minus 1. Okay, so we did it. Okay, so this thing is the value. This is the value of the nth term in your sequence, right? And then usually they write this formula as an equation where they say a sub n is equal to a times r to the n minus 1, where this is your starting number. Sometimes they call this initial value, the initial value. Okay. In computer science, this starting number, sometimes they call this a seed. Okay. So here you could think of it as like you start with the seed and then it grows or something like that. Okay. I think that's more intuitive, but yeah. Also different notation. Sometimes they call this a sub 1. It's equivalent to this. Okay. But just so long as you have the idea, then you'll be able to look at any variation or form of this formula and still understand it. Okay. This r represents the common ratio, And then this n minus 1, well, that's just the exponent, right? And then this n represents the nth term in your sequence. Okay. Okay. All right. And n here, okay, so here, if you want to be more precise with this formula, we can place like an appropriate bound on this, like the domain, right? So here, I started my index, right? So the list, I started to count it off as the first, right? Sometimes in textbooks, they like to start this off at 0 because I think also in computer science, a lot of the, yeah, they in lists and stuff, they start with 0, right? But yeah, but just know that depending on the context, you might want to change this. But in the way I wrote it here, this is going to say here, this n is, it's just a natural number. So where n is greater than or equal to 1. Okay, natural number. Okay, so now the questions that you can find, like you'll be asked, are like, oh, find the 99th term of the sequence. So if they say something like, find the 99th term of the sequence, then that's low-key asking you find the, okay, yeah, it's, sorry, I have to delete this because I'm not that good with the subscript typing, but a to the 98, a to the 99, a sub 99. So when they say find the 99th term of the sequence, that means you need to find this value. And the way that you do that is equal to, you take this starting number, you put the a, and then you take the common ratio r, and then 1 less than that is 99 minus 1. In other words, a to the r to 98th power, okay? And then this just becomes a substitution exercise, and you just plug in, okay? All right, so guys, once again, you already know, majority of the times these are take one vids. Let's keep it that way. And if it goes bad, and yeah, we'll see. Okay, but hopefully this is okay. I'll be making more videos, so that maybe smaller videos. I know that the students like those, and I don't have to like go do like full lessons on these things. Okay, and then just sticking to the main topic. Okay, all right, guys, see ya.